So in this next example, we're going to look at the binary search. Remember, the binary search is more efficient than the linear search because, in fact, we're going to progressively cut our data set in half so that we're not searching the full data set. As a matter of fact, we're not even searching remotely as much as the full data set by the time it is we get to really, really big data sets that we would be looking at. So over here, I've got the general setup. We still have I was just lazy and I copied the code from the previous one. So because the previous example was 16 characters, this happens to be 16 integers in an array. And this time, instead of linear search, we have a binary search. But it's working on very, very much the same principle here. We are passing an integer array to our binary search algorithm. We are also passing along another integer. That integer represents the size of our array. And finally, the third integer here is the value it is that we are looking for. So here you can see my integer array. I'm just setting this up as part of the gestalt for what you might need for the end of chapter exercises is, could you read values from a file into an array so that you don't have to hard code them here? Yes, you can, because you're going to have I think the technical term is boatload of names to have to deal with here instead of integers. Just foreshadowing. So what we are going to do is enter a value to search for. We are going to take integer values here to search. And just like in the previous example, when we were doing a linear search with characters, here we're going to take a return value from our search function. -1 for was not in this array, or the value and its position if yes, it was in the array. So here you can see our binary search function. Just a couple of things so that we can get this set up. We're going to need to know what the first element is that we are looking for. So the very first time through, the first element is going to be 0. But the next time through, we're going to be dealing with either the first half or the second half of the alphabet. So we need to be able to potentially move where the first element is from 0 all the way to whatever our middle value, our middle element would be. And then we have to have last. So that's our number of elements -1, because, again, remember, here I'm saying that size is 16. But we have to essentially convert that to, array element indices, because the last element of our array is n-1. If we do not account for number of elements, or last rather equals number of elements -1, if we do not account for that, we're going to check outside of the bounds of our array, and that leads to a logic error. We also need to have to know what the middle is, right? Because I take my first element, my last element, I divide that by 2, and that's my middle. So here on line number 42, while, so I'm going to keep doing this until a condition is met. It's really one of two conditions because we can return what that value is. Either you keep running until you find it, or you keep running until first is less than or equal to last. What we're saying here is, if you think about the distance between our first element and our last element, it's going to keep getting closer and closer and closer and closer. And at some point, that value is going to be the same. Your first element and your last element are going to be equal to each other. And at that point, either you have located what the search string is, or it ain't in your data set. So that's what we have the while first is less than or equal to last for, because that covers you all the way down until you have run out of value or elements really to check against one another. So middle equals first plus last minus first divided by 2. That way, it's we can consistently move what the which data set it is that we're looking for, greater than or less than what the search came up with. So if, here we go, array at middle equals value, you can just stop. So that means, look, if you've taken your data set, you divide it by 2, and somehow wonderfully, miraculously, it happens to be the thing that you're looking for, stop now. Otherwise, keep going. So we're saying, again, look at the data set then. If the value you're searching for didn't happen to be the one in the middle the first time that you have looked, if the array or if the value in the element is less than what you're looking for, you know which way the middle goes. If the value is greater than what you're looking for, you know the middle goes the other way. So it's really very, very elegant. It seems like that's insane. How does that? It works remarkably quickly. Again, I always get this look when we have you in class. Like, are you kidding me? These 13 lines of code, including white space and descriptions, can go through a data set of any size? Yeah, they really can. This is really all you need to be able to sort through a data set of any size and either return what element that search for value is located at, or it ain't in there. So I'm going to run this, and we're going to see over here in the output window. It's going to ask me to input an integer that I'm searching for. So I'm going to look for 0 because it's the last one. And it says the value 0 is in position 16 of the list. That is what we were looking for, right? So because we're not doing the -1 to do it in array element speak, right? So that's why we don't see a 15 here, because it's based on size. It is not based on the n-1 for your array. So I'm going to run this again. We're going to look for 12. And now here's where something interesting happens. So if I look for 12, before I even hit enter here, you are going to notice that I actually have 3 12s in my data set. The value 12 is in position number 8 of the list. So here it tells me the value is in position 8 of my list. However, look again. We've got 2 more 12s here that are essentially unaccounted for. This is a weakness of the way that we're searching our array. We are simply saying it. We are using this as a flag, not how many times does the data show up, just does this searched for data show up. Now, I'm going to say that that's okay for right now, because actually we'll see it again later on when later on when we are looking at, I believe it's chapter 11 here. But for right now, that's not something that we're going to have to worry about. We are just go, no go. It is or it is not in this data set. So finally, we'll use a number that is not in our data set. We will search for 99, and the value 99 is not in the list. So here is the code for the binary search. In this particular instance, we have it set up so that we are looking exclusively at an integer array and exclusively for integer values. One of the things I am not talking about in either one of these 2 video sets, either the chapter videos or the code sample videos, is the idea of the overloaded method for this, because I know you know what an overloaded method is. I know you know how to create those in the code and how you would be able to use those. So I don't think it's a huge stretch of your imagination to be able to get there, but I could overload this for strings and integers. I could overload this for doubles and strings or doubles and characters or whatever the case might be.